Hello friends, welcome to my channel Academic Made Easy PC. In the previous videos we have learnt about relations. Today we will be learning about functions. First let's see what is a function. A function is a relation between a set of inputs and a set of permissible outputs with the property that each output is related to exactly one output.
So now let me say you all a real life example. On a particular day you have two functions at a time. Will you be able to attend both the functions that time? Of course not. You can attend any one function only. So the same way in functions also the same concept is applied. So one element can attend only one element in the code domain. That is, one element can be mapped to one and only element in the code domain, that is range. Okay, so no element will be mapped to two elements in the code domain. That is the concept of function. If not, it is not a function. I think you will be clear with this concept. So now let's move on to the concept of functions.
So now let's see an example. Let A and B be any two non-empty sets. Mapping from A to B will be a function only when every element in set A has one and only image in set B. That is set A and set B. Set A containing the elements 1, 2, 3 and 4. Set B containing the elements A, B, C, D and E. Now if we see this example, it will be clear, I think. Every element is mapped to one element in the code domain, so automatically it is a function. So this is a function. And one more type of example is that the same set I'm taking. So if I map 1 to A and 2 also to A and 3 to C and 4 to D. If I map like this also, it is a function, because just think of that function that in a real life many people may attend one function. Okay, so only one person cannot attend many function, but many people can attend one function. If you are clear with that, this one will be a clear part. In many elements from the domain can be mapped to one element in the code domain, but one element in the domain cannot be mapped to many elements in the code domain for a function. So here this is a function. This next example, the same example, but I have mapped 1 to 1 element, 3 to 1 element, 4 to 1 element. But if I see here 2 is mapped to B as well as C. So one element in the domain is mapped to two elements in the code domain. So then this is not a function. Now let us see what is domain and what is range. Before seeing the definition, I would like to say you all an example, then let's move on to definition. Okay, so now we know what is a function, and now we have to know what is domain and what is range. Function from A to B. It means I'm taking a function from A to B. So A will be mapped to B. Then this part A will be domain. Set A will be domain and set B will be codomain. Okay, so now we have to know what is range, isn't it? If I map 1 to 1, if my function is f of x is equal to x square, f of x is equal to x square, I will be mapping 1 to 1, and 2 square is 4, 3 square is 9, and 4 square is 16. So I don't have any other element in the domain, so I'm just leaving it just like that. So what will happen now? So this element, this every element is a codomain. Altogether is called a codomain, but the mapped elements 1, 4, 9 and 16 is range. So Now we will be writing here what is domain 1, 2, 3 and 4. This is domain. And what is range? Range means the mapped elements. So what are mapped? 1, 4, 9 and 16. Okay, so now what is a codomain? Every elements in set B is called a codomain. So 1, 4, 9 and 9, 16 and 25. Domain is nothing but all the elements in set A. All the elements will be mapped to some element in the codomain. Codomain is nothing but all the elements present in the set B. Next, what is the range? Range is the elements that are mapped. First, for domain, if a function is expressed in the form of y is equal to f of x, then domain of f means set of all these real values of x for which y is real, that is y is well defined. So all the elements that we saw in set A is domain. Okay, now let's see what is range. If a function is expressed in the form of y is equal to f of x, then range of f means set of all possible real values of y corresponding to every value of x in its domain. So corresponding values, that is this one we saw, isn't it? The corresponding value, that is the mapped elements, is called range. I think domain and range is clear now. What is the difference between relation and function? So first, relation and function. A relation from a set A to another set B is any subset of AB. Anything that we take will be subset of AB depending on the condition only. But in function, a function f from A to B is a subset of A cross B, but satisfying all this. Now this symbol represents for every, and this symbol represents there exists. Okay, so for every x belonging to A, there exists y belonging to B, such that x comma y belongs to f. If x comma y belong to f and x comma z also belong to f, it means y is also equal to z. The next is, there may be some elements of A which are not related to any element of B. Function, each element of A must be related to some element of B. So I already said you, in the domain every elements are mapped, but in codomain that is not needed. But in relation, this some elements will not be mapped to some elements. That is the difference. In relations, some elements may not be mapped, but in function every element will be mapped. Next difference, an element of A may be related to more than one element of B. An element of A should not be related to more than one element of B. I already said you in the introduction of functions, I said no element can be mapped to two elements in the codomain. Okay, that is for function. You will be clear with this point for function. And for relation, one element can be mapped to two elements also. That is the difference. So important note to be made, if the domain and range of the function f are subsets of R, that is real numbers, then f is said to be real valued function of a real variable or real function. If domain and range has real numbers, then it is called real valued function of a real variable or a real function. Now let's move on to the important concept, that is types of function. One-to-one function, on-to function, many-to-one function, constant function, into function, bijective function. Now let me explain you all one by one. First, one-to-one function. Now let me say you all an example, then we'll move on to the definition part. So I'm taking a function f of x is equal to 2x. 2x means x takes the value in the domain. Okay, so I'm taking this one. So if I map the elements, I'll check whether I'm getting one-to-one function or not. Let me do this example, then explain you what is one-to-one. So if I take 1, if I take 2x, then I will have 2. 2, here 4, and here last. That's it. One element from here is mapped to one element from to one element to 1, and one more element to one element only. No two elements are sharing one element in this codomain or range. So then it is called one-to function. From one element to one element, it is called one-to-one function. So now if I take over here, if I have 1 to 1 and 2 also to 1, 3 to 3, 4 to 4 itself. So if I take like this 1 to 1 only, and here also 2 to 1, so it means many numbers to 1. So it may be many to 1 also. So you have to be clear with 1 to 1 and on to. Now let's move on to the definition part. A function f from x to y is defined to be one-to-one or injective if the image of distinct element of x under f are distinct. That is, for every x1, x2 belong to x. That is the set x. F of x is equal to f of x2. This is the condition. We take this condition, we have to get this answer. Then it is one-to-one function. If not, x1 not equal to x2 means it is many to one function. One-to-one function is also called injective. For example, we'll take the real life example. Injection is used for only one person and it is thrown in the dustbin. So just like that, injective function means one to one only. Injection for only one person, not for many person. Just like that, injective is one to one. Be clear. Now let me say how to find the number of one-to-one functions from A to B. So if we have number of elements in A as m and number of elements in B as n, then the number of one-to-one functions will be n, p, m if n is greater than or equal to m. The number of elements in B is greater than or equal to number of elements in A, or 0 if n is less than m. That is, number of elements in set B is less than number of elements in set A. This is the condition. Let's see what is onto function. So before that, let's see an example. So here my function, I have taken it as f of x is equal to x square, and here also f of x is equal to x square. So now let me have this set as set A and set B, and this set A, set B only. Then if I take this one for f of x, 1 square is 1, 2 square 4, 3 square 9, 4 square 16. So when range is equal to codomain, if this condition is satisfied, then the given function is onto. Okay, I think you will be clear now. Next example I'm taking here. So the same thing, isn't it? So 1, 2, 1, 4, 9, 16. So now here one element is left over here. Even if one element is left over, then it is not onto, because the condition for onto is codomain should be equal to range. The function f from x to y is said to be onto or surjective if every element of y is the image of some element of x under f. That is, for every x belonging to y, there exists x in x, that is set x, such that f of x is equal to y. Okay, now let's see what is number of onto functions from A to B. If A and B are two non-empty sets having m and n elements respectively, such that 1 less than equal to n less than equal to m. This is the condition. Then summation r is equal to 1 to n minus 1 power n minus r into NCR into r power m. This is the formula that should be used to find the number of onto functions. So now let's see what is a bijective function. If a function satisfies one-to-one and onto condition, then it is a bijective function. For example, see, now I'm mapping 1 to A 2 to B, 3 to C, and 4 to D. So this is one to one function, as well as this is onto function. So then it is called, it is bijective function. Bijective function. I think you will be clear now. Now let's move on to definition. A function f from a to b is bijection if it is one to one as well as onto. That only I explained you already. It is one to one. The condition for one to one is written over here, and the condition for on to is written over here. When we do the sums, I will explain you more and more clearly. To find the number of bijections, if A and B are two non-empty sets having n number of elements in set A, we are seeing only the set A. The number of bijections is n factorial. This is very easy formula to find the number of bijections. We'll move on to into function. If all elements in the codomain are not the image of domain, then it is called into function. So let me give you an example. 1, 2, 3, 4. And I have minus 1 over here. So I have f of x is equal to x square. Okay, what is x? 1 square? 1, but I don't have here. 2 square? 4. 4 I don't have here. 3, 9. 4, 16. I don't have anything. I cannot map these two sets. So then it is called into function. If all elements in the codomain are not the image of domain, then it is called into function. Over. Next, constant function. Constant function is nothing but, for example, I have 1 over here and I'm mapping to A, 2 to A, and 3 to A. Then if all the elements are mapped to one element in the codomain, that is, the codomain consists only one element and all the elements in the domain are mapped to this element, then it is called constant function. A function f from a to b is said to be constant function if every element of a has the same image under function b. F of x is equal to c, that is some constant for every x belonging to a where c belong to b. That's it. Then identity function. Identity means what? Looking similar. The same thing here also. A function f from a to a is said to be an identity function on set A if f associates every element of set A to the element itself. Thus, f from a to a is an identity function if and only if this represents if and only if f of x is equal to x for every x belonging to a. So let me give you all an example. I have 1, 2, 3, 4 in set A. So here set A, if I take also 1, 2, 3 and 4 only I'll have. So I'm mapping this all to itself, isn't it? So every elements are mapped to itself, means 1 to 1, 2 to 2, 3 to 3, 4 to 4 itself. Then it is called an identity function. So the types of functions is over.
Thank you for watching my video.
Like, comment, share, and subscribe.